All right, so this is going to be my summary video of mesh analysis. I'm not going to spend too much time, not as much as I did with nodal analysis, because mesh is a little bit quicker. But at the same time, I just wanted also to keep these videos as brief as possible. So mesh analysis, let's go here. All right, so if I have a circuit like this, I'm only going to solve so much of this. Really my goal here is really just to show the different steps here. Again, here are the steps listed out here. So I have 5 steps: assign currents to branches, predict current loops, apply Kirchhoff's voltage law this time around, reduce the system's equations, and then solve for the current loops here. All right, so let's go step by step. And again, I can send these notes to you, and you can see if you can just match the pieces up. And yeah, hopefully it helps when it comes to reinforcing the content. So first, assign currents to branches. So the currents to branches are going to be these right here. So I've assigned these. So I have 3 currents. I'm just going to go ahead and assign them. Again, can I be wrong? Yes, I can. But as long as I'm consistent, the math will all work itself out. So one thing that you might think is suspect here is I3. You think, hey, P-Stan, wouldn't you want to guess I3 to go up because the voltage source is there? Sure, I guess. But I also want to go, now I'm just thinking ahead to step 2. But I want to go clockwise with everything. So I just want to keep all my current arrows consistent with that. So for me personally, I just want to keep it consistent, but you are more than welcome to flip it around and yeah, try it out. See if you did flip I3 around, see what your math comes out to, and we should still end up with the same conclusion. I wouldn't say same results because you might get a negative, but we'll come out with the same conclusion in regards to, hey, this is, the final result is really this. So what that really says is the current is flowing in a certain direction and whatnot. That's it. All right. So once I've identified the currents on each branches, I'm now going to predict current loops. I know sometimes some people like to predict it first. I personally like to start with the branches because you may be given a circuit that has lots of meshes. So if you want to think of like a window that you see in a house, you have all the different, you have those windows with the different metal things in the middle. Usually it's a piece of plastic or so. So this is kind of like quote unquote the Windows method. Sometimes you may see lots of those and you may wonder, hey, I'm going to use mesh analysis. Well, I don't know. We'll see. If you actually identify the current branches, you may actually think different and may think, hey, maybe I should use nodal analysis instead. But anyways, next thing you want to do is predict the current loops. In this case, a little bit easier. And what I did was identify these as the 2 current loops to counterclockwise. I identified one as the loop of I1 and the second is the loop of I2. So these are currents. Next, applying Kirchhoff's voltage law. Kirchhoff's voltage law is right here, as you see. So I want to apply KVL at each of the loops. So Kirchhoff's voltage law says that if I go around the loop, it should be the sum of 0 because of conservation. So I'm not going to go through that step by step, but you can kind of see my work here for each of the loops. What I did was I started at the source and then I went around this way because that's how I identified I1. Same with here. Same with the I2. I think here what I did was I started up here and then I went down this way. Yes, because it's negative 6 I2 like so. All right, so that's what I did there. All right, so after that, I guess one question that students are going to ask is, hey, my resistors, I'm not adding any sort of like convention here, plus, minus, etc. Yeah, I mean, I don't have to, because the way I think about going over, whenever I go over a resistor, I always think it's going to be some sort of drop. If you want to write those in, you can. But to me, just what does a resistor do? That's the big question, right? Well, a resistor is going to resist charge, it's going to resist current. Therefore, to me, at least what makes sense is it's going to drop. So every time something hops over a resistor, as you see here, it's going to be a minus like so. But again, it's also dictated by the arrows itself. So you want to make sure you keep that in mind. So for example, very quickly, try not to ramble too much. I have a positive 10 I2 like you see right here, right? So that's going to come because what's happening is I2 is coming up this way, which is opposite of the loop or the direction of the current. Therefore, it's going to be a rise, even though it goes against the current flow. Again, the main thing is be consistent. All right. Fourth step, reduce to systems equations. So you'll notice that everything is in terms of I1 and I2 on my Kirchhoff's-Volch law equations. So you notice that there's, let me get this pen, I1s, I2s, and everything else is constant, right? So we're gonna go back to our good old linear algebra. If you have taken linear algebra, it's totally fine. System equations is a simple algebraic procedure method. So what you end up with, if you were to reduce it, is this equation right here. What I did was I just multiplied the numerator by 2, so I can get rid of the I2 just really quickly. So it's just a quick trick that I like to do. You can solve it however you want. You can use MATLAB, you can use any other method, but I did this way so that I can identify, so I can start solving the current loop. So I1, I found that to be 1 amps. And then for I2, just plugging it back into another equation, I found that it's also 1 amp as well. So kind of skipping, so kind of moving forward, but naturally, once you reduce systems equations, you end up solving for the loops. So what I can do is I can go ahead and actually now identify that I1 is equal to, oh, here's my solution here. So I1 is equal to, little I1 is equal to big I1, I2, little I1 with big I2, and I3 is going to be the sum, or in this case, I1 minus I2 there. All right, so that just concludes my video for mesh analysis. And yeah, the next video is going to be me solving one of our guest speakers examples.